All right.
Hello, everybody, and welcome to this live session of Azure Back to School. With me today, I have Elkhan Yusubov to do a great presentation on cloud design patterns. This is his second live session of Azure Back to School. I know a lot of you have taken a look at his AZ305 prep session. I believe that's one of the more watched sessions of Azure Back to School. Actually, Elkhan, just to
Thank
let you
you,
know,
everyone, for doing that.
I was looking at some of the data yesterday and saw that a lot of people have gone back and watched that on demand. So thanks everybody for
Nice.
that. Thanks everybody. Thanks to all the contributors. We're on the home stretch. It's the 27th day of Azure Back to School on the 27th of September. So we've only got 3 days left, but you can access all of the material at azureback2school.github.io, and it will still be available. The schedule and all the links to all the material can be found there, as well as be found on the YouTube channel uh, after we finish things up on September 30th. So, without further delay, Elkhan, I will turn the floor over to you and have a great session.
Thank you, Captain Scaler. And hello, everyone. Welcome back to this session. This is the second session on Azure Back to School. And thank you. If you take your time to watch the how to get, Azure, what are the changes and what are the update on Azure Architect exam in 2023. So in this session, we are going to more focus on cloud design patterns. But before doing that, I want to say again, big thank you and shout out to Dwayne and Derek for organizing Azure Back to School event. And this is the, I believe third or fourth year in a row that they are doing. It's awesome initiative, and all the speakers, including Microsoft and Microsoft MVPs, Microsoft employees and MPVPs, they try to share their knowledge and latest with the community. Thank you all the viewers for coming to my second session here, and I hope you will like this one as well. And thank you for considering your time to learn more about cloud design patterns. And of course, thank you for my family, my kids, and wonderful wife for making it possible for me to prepare this session for today. So we are going to talk about cloud development and migration to utilize cloud services, and this is a very hot topic, right? So getting maximum benefit from the cloud does require some careful approach, designing your new application, refactoring the existing ones, or basically looking at the greenfield or brownfield, depending where you are in your project. So that said, before jumping into the cloud design patterns, thank you, Dwayne, for introduction. And this is a little bit information about myself that you see here on the screen. And I'm not going to stay too much here because probably you see that one on my previous. So I am a long-time MCT from 2007, have been enjoying instructing and learning about Microsoft products, especially in the last 8 years. I was doing more of a Microsoft Azure training and classes for my students. I'm a Microsoft Azure MVP and very honored to be one of those people who are re-awarded this year, and it's a great recognition by Microsoft. Thank you for the great community of people that they are bringing together. I'm also a founder of the Cloud Marathoner hashtag that you can see on LinkedIn posts that I'm sharing, and the main idea there is to share cloud and Microsoft Azure journey roadmap, but I'm trying to include a multi-cloud approach as well, and others, AWS and Google Cloud information, including security and automation, can be found in my posts. I'm active member of Cloud Launch and Learn. You might see me presenting there or maybe moderating some other speakers. You are more than welcome to check that one, the Cloud Launch and Learn channel, and it's part of the Cloud family events. Okay, that's enough about myself. I'm pretty sure some of you are watching this live or you are going to watch it later on. Please say hi in the comments. Let me know that you join. And if you have any questions, do not hesitate to bring them up. Next, you see a compact infographic about T-Rex solutions. That's where I'm actually employed and what we are doing at T-Rex. It is one of the best companies in the area where I work on delivery of mission critical cloud-enabled solutions to our customers with our team of engineers and architects that I'm happy to lead. We have strong partnership with CSPs, cloud solution providers, and our company does support development of local communities in the areas. So if you are open for new opportunity in the market, then check out our open positions or reach out to me directly via LinkedIn or any other means. And I will share my connections at the end of the session. So let's jump and see what we will cover in this section, right? In this presentation. First, we will start by looking why architecture matters. Okay. Then we'll look into what is the cloud architecture, and then we'll look into design patterns, how they come up, and what type of beauty they or importance they bring into the solutions, especially technical solutions, and what are the cloud design patterns. And then we'll have a short Q&A at the end of the presentation. I hope that sounds interesting for you. I'm going to share a lot of reference information so that you can go ahead and deep dive more after this session. But I'm also going to post this presentation into my GitHub repo, which I'm going to share with all of you so you can go and check it out after the session. All right, so let's start it. So let's look why architecture matters. So as you see on this diagram, right, which represents a number of technical people who are came together trying to do some work, right? Some of them are sketching on the board. I- The architecture itself is about building a sounding solution. You should base your approach on successful patterns and processes. And as it is in this infographic, it provides a glimpse into the process and steps, right? That the team that's there trying to take in order to build a set of buildings. As you see on the right edge here, the person is trying, let me actually take my laser point. So person here on the right is actually trying to show, and they are collaboratively working, right? So next, it shows that architecture cannot happen in the vacuum, right? That's um, the architecture cannot happen in the vacuum, so it involves stakeholders, right? And in addition to that, there are some other things that we should consider as well, like identifying the scope of the solution, what we are, covering, what solution is going to do. But before even identifying the scope, we have to identify the requirements. We have to involve the stakeholders who are defining these requirements for the solution. Then it's really, really important to have some type of uh, POC, proof of concept. So you want to have a team of capable engineers who can work on that proof of concept. Then, of course, you have to, in order to, when you start the inception of the project that you architect for, you need to have a team to build that, right? You need to have a team, cross-functional team who can deliver on that. And there are many other things. But you may also ask, okay, so what is the what it takes to build an enterprise level architecture. All right, so what it takes to build enterprise level architecture, and to answer that, it's actually makes sense to bring a use case that I'm familiar with, and it could be great to share with everybody in the audience. So let's consider this real life example of the solution that T-Rex solutions did on and is doing, continuing doing for the Census TI 2020 program. It has been delivered again by the TRX Solutions, and illustration that you have here is the high level points in this infographic. So this was a mission critical solution, and it was a massive, that's equal to mobilization of approximately 20,000 people to deliver this work. And of course, all these 20,000 people, they were not just architects and engineers, but there were a lot of information workers who were dealing with the all different stages of the census program. As it illustrates in this infographic, it involved a huge scale with complex scopes and deliverables. As you see, there were uh, initially there were 52 separate systems that get combined into 18 mission critical systems by migrating into the cloud. Then it involved a number of different ATOs, authority to operate things, so that everything that you design and you install, they are running under the specific compliance, and they are compliant with the government regulations. And then in addition to that, the scope, right? As you see here, okay, in the scope itself was very important. It was a hybrid solution, meaning that it wasn't just migrating everything to the cloud and running there, but there were critical systems on-prem that have to be connected in order to provide the solutions. And in addition to that, you had business architecture, you have DevSecOps, you have operations and centers, you have like very different components that need to talk each other and work together. So that's where you have to consider all different stakeholders, all different subsystems, and find the solution, how to migrate them, how to make them work together in a compliant way that's operational and meets the customer requirements. Next, let's look at what is the cloud architecture. And probably the easiest way to do that, the diagram that you see here on the right side, is actually coming from the Wikipedia. And if you look at the Wikipedias in terms of what is the cloud architecture, you would see that it says that cloud computing architecture refers to the components and subcomponents required for the cloud computing. These components typically consist of a front end, right? Um, that front end platform that can be a thin client, it can be a mobile app, it can be a fat client. You also need to have a backend platform which has the server, storage, and then you have a cloud-based delivery, and as well as the network, which can be your internet, intranet, or intercloud. When you combine all these components, that's where you get the cloud computing architecture uh, in place. So the backend refers the backend component here refers to the cloud architecture components that make up this cloud itself, including the computing services, storage, security mechanisms, management, and more. Okay, that said, but we here to learn more about design patterns, right? So let's now switch our gears and look how it looks like. What is the design patterns and where it come from? All right, so this is another very comprehensive diagram where, as a software architecture design, in as you see in the software architecture, patterns are also coming from. They are the basically where the initial place where design patterns started. And software architecture design patterns are reusable solutions to common problems that occur during the design and development of software systems. These patterns help software architects and developers create robust, maintainable, and scalable software by providing the tested and proven design solutions. So in this diagram, if you look attentively, you would see that one of the very well-known elements of design is MVC design pattern. Stands for the model, you have V, which is the view, and C controller. In addition to MVC, if you are coming from the software development background, you know that there are different models like MVVM and others. It's a variation of the MVC. In addition to that, you also have some traditional pattern here, broker pattern, that displayed here on, you know, with this purple box and connected components here. So this is what the design pattern basically. These are the elements of design pattern, just small example, but gives you idea in terms of where they are coming from. That said, let's consider some specific software architecture design patterns in the next slide. Okay, so when we start with specific patterns, there's a way how you can group them. And maybe some of you are actually already familiar with that. But before diving into that, let me check the actual chat and see if there is any comment or anything. And I don't see anything. But in the meanwhile, if you have any questions, please feel free to put them there. Okay. All right. Let's go back now. Okay. So here, in terms of design patterns, there's a common way, agreed way that they are grouped together. And this is a creational pattern, structural pattern, and behavioral pattern. So if it's creational patterns, as it is, one on the top here, it's as the name suggests, creational patterns have a lot to do with the creation of the objects. These patterns are designed for the instantiation of the classes. Creating the objects required in the conventional format may result in additional complexity to the software design or even the design problems. So creational design pattern solves the problem by controlling the object creation itself. Then we have a structural pattern, and these structural patterns are useful in creating larger structures from smaller individual parts that are in general coming from different classes. This pattern can also be used to ease the design by reorganizing a basic method of recognizing relationships among the entities. And then we have a behavioral pattern, which is uh, about those design patterns that are described and identify the interactions between different objects. Making use of behavioral design patterns can reduce complicated flowcharts of the software design into simpler interconnections between different objects of the classes. So in addition to that, for the software design architecture, um, for the software design and architecture stack, you can see that depending on the scope, you may consider different design patterns. And here on the, as it is here on the right side, uh, you can have some different enterprise patterns for domain models, with some of them, DTOs, mappers. Then you can have some of the architectural patterns that we talked about, like MVM, uh, DDD, which is a domain-driven design. Then you have architectural styles, and there are a number of others, which I'm not going to list all of them here, but these are the some of the well-known software design architecture patterns. But that's not all, right? Because this is all good, but we are here to learn more about cloud design patterns. But uh, I wanted you, before jumping into the cloud design patterns, understand that those things are mostly coming from the software design patterns, which were built mainly for distributed systems. So let's now jump into the cloud design patterns. Okay, when we speak about cloud design patterns, it's a good idea to check, of course, the main cloud solution providers that you see here on the screen. We have AWS, Google Cloud, and Microsoft Azure. So why knowing or learning the cloud design patterns important or helpful? Well, in the cloud-based systems, failure is going to happen for sure. That's something that, you know, we don't want to happen, but we have to plan and design for the failure. And your architecture needs to focus on eliminating a single point of failure that can bring down the entire system. Okay, and to do that, cloud solution providers, they come up with some common design patterns that have been derived from that distributed systems, software architecture in distributed systems. So AWS has its you know approach on cloud design patterns. We have GCP and Azure. So let's look at them on the side. So let me bring the browser here for a moment. And yeah, so let me know if you see this. You can put the thumbs up in YouTube. I don't see the chats coming here, but if you are there, just put the thumbs up so we know that everything is there. The first one is the cloud design patterns, architecture, and implementation that's coming with on AWS side. The one that you see here is defines them on a high level, and After that, it dives into some of the patterns that are covered. So you see that we have anti-corruption layer, we have circuit breaker, and others here listed. So I'm going to bring those and actually share with you as well. So next, this is the, and I'm going to share the link so you can get the links at the end of this demo. Next, we have this Google Cloud Architecture Center that provide design guidance. So their design guidance is more toward like, specific components. However, if you want to find more about them, they're defined here and they're reusing some of the well-known design patterns as well. And next, we have the Microsoft Azure that comes with own cloud design patterns. And based on the challenges, they divide them in some groups. But if you scroll down here under the catalog of patterns, you will see that the same design patterns, like anti-corruption layer, circuit breaker, claim check, that's another, design pattern. They are all there to support the mission. So that said, uh, these are the main design patterns. Let's go back here and let's uh, uh, let's do the following, right? So those cloud design patterns that we just showed on the AWS, Azure, and GCP sides are same, or each of them have different approach, right? That's the question that you may have because, okay, so we saw them, are they same or not? So it actually, in the nutshell, they look common. So that's why there are some common cloud design patterns that you can rely on when you are trying to architect certain mission critical systems so that your system is ready for the failure. So to do that, we are going to go and look at those common cloud design patterns. So if there are any questions till this point, I will pause here for 5 seconds. And if when you see any questions or any comments, you are more than welcome to come back and let me know.
Nothing thus far, Alhan. Keep on.
All right. Thank you for checking up. All right. So going back, so we are at this common cloud design patterns part. And as you see here on the left side, we listed some of those common cloud design patterns that are taken basically from the main cloud solution providers, from CSPs. And the main point here is that these design patterns are useful for building reliable, scalable, and secure applications in the cloud. And as you see, each pattern describes the problem that the pattern addresses. So considerations for applying them is something that you need to check the problem statement and what you are trying to deliver. Most patterns include that some of the code samples and snippets that you can start with, and it gives you some guidance on specific cloud. However, most patterns are relevant to any distributed system, whether it's hosted on AWS, Azure, or GCP, or any other cloud platform. So if you start with the one on the top, I'm going to cover some of them here, but then we'll deep dive into each of them and look into their, you know, look at the problem they are solving and look at some, graphic where we can better understand, okay, what is this design pattern, what it is supposed to do. So let's start with the first one, anti-corruption layer. So what it does is basically it implements a facade or adapter layer between a modern application and legacy system. Then we have here circuit breaker. So what it does, it handles the faults that might take a variable amount of time to recover from when connecting to a remote service or resources. This can improve the stability and resiliency of an application. Next, we have here claim check. As the name suggests, it splits a large message into a claim check and payload to avoid overwhelming a message bus. Then there's a retry with backoff, or also known as a retry pattern. This will enable an application to handle anticipated temporary failures when it tries to connect to a service or network resource by transparently retrying the connection behind the scene. That's previously failed. So if there's any transient error, it would be able to retry and come back and work on it. Then we have, other like Saga orchestrations, Strangle Fig, and others. But instead of just going through them, I think it would be helpful consider some of these patterns in depth. So let's have a little bit, deeper dive into the first pattern, which is the anti-corruption layer. All right, that's how it looks like on a high level if you want to describe anti-corruption layer. And again, if you remember the main point of implementing this cloud design pattern is you if you want to have a facade or adapter layer between a modern application and legacy system. So here, let's say the subsystem B is your legacy system, and on the left side you have a more modern microservice architected system. So the problem statement here is that most applications rely on other systems for some data or functionality. And as we said, for example, a legacy application is migrated to the modern system. It may still need existing legacy resources to operate. New features must be able to call the legacy system. This is especially true of gradual migrations, where different features of a large application are moved to a modern system over time. So what is going to be the solution, you may ask? So when you isolate the different subsystems by placing an anti-corruption layer between them, this layer translates communication between the two systems, allowing one system to remain unchanged while the other can avoid compromising its design and technological approach. And as it is on this diagram, it shows an application with two systems that we described, right? So we have a subsystem A on the left side, and we have a subsystem B on the right side. Subsystem A calls to subsystem B through an anti-corruption layer that's defined in the middle, and communication between the subsystem A and the anti-corruption layer always uses a data model and architecture of the subsystem A. Calls from the anti-corruption layer to subsystem B that we have on the right side conform to the subsystem data model or methods. So the anti-corruption layer contains all of the logic necessary to translate between the two systems. And that layer can be implemented as a component within the application or as an independent service. All right. So when to use this pattern then? So if you have a migration or you have a migration that is planned to happen over multiple stages, but integration between the new and legacy system needs to be maintained, this is one of the good places to try it. Next one is if you have two or more subsystems that have different semantics but still needs to communicate and work with each other, that's another use case where you can have it. So but when we should not use this, or what is not a good application to use the anti-corruption layer, this is when you have a this pattern is not going to be good or suitable if there are no significant semantics differences between the new and legacy system, meaning that if your uh, new and legacy systems, they have same semantics, meaning that you don't have different data stores that represent different parts of the systems, and you don't have much of the difference in understanding the communications, then this is going to be an extra layer if your subsystem B looks as a subsystem A. There's just no need to do that. So I hope you find this interesting. So if you have any question about the anti-corruption layer pattern, please put that in the chat and Wayne will let me know. Next, let's jump into the cloud design pattern called claim check pattern. So the main point here is that with this pattern, you can split a large message into a claim check and a payload to avoid overwhelming a message bus. So splitting a large message into a claim check and a payload makes it easy to send the claim check to the messaging platform and store the payload to an external service. And this pattern allows large messages to be processed while protecting the message bus and the client from being overwhelmed or slowed down. This pattern also helps to reduce costs, as storage is usually cheaper than resources units used by the messaging platform. So, as a context and problem, I guess you already kind of may have some understanding or mimic some problem that they solve. It is intended for the messaging based architecture at some point where you must be able to send, receive, and manipulate large messages. So if you are dealing with large messages, this might be a helpful pattern to consider. Such a big message may contain anything, including like images. It can be big images that coming from MRI scans in healthcare, can be sound files that are very big because it's high quality, and it can be also call center calls or text documents or any kind of binary data of different sizes. So sending such large message to the message bus directly is not recommended when you are dealing with large size uh, data because they require more resources and bandwidth to be consumed and processed. So that's why large messages can also slow down the entire solution because the messaging platform are usually fine-tuned to handle huge quantities of small messages rather than deal with the big size messages. So so that's why most messaging platforms have limits on message sizes. So you may need to work around these limits for larger messages. So as a solution, we can store the entire message payload into an external service, right? It can be a storage account, it can be a database, depends on the type of object that we are, trying to save. And then we can get the reference to the stored payload and send just that reference to the message bus so that the references acts like a claim check used to retrieve a piece of luggage. So that's where the name of pattern is coming from. So clients, meaning that this consumer of that uh, message who are interested in processing that specific message can use obtained reference to retrieve the payload and work on that message. So as you see here on this diagram, it's also well annotated in terms of steps. So this is the first step when message with data is actually sent by the application. Then at the step 2, uh, we are storing the message on the data store. Then at this step 3, we enqueue the messages reference. All right. And then at the step 4, we are reading the message reference by the receiving application, and then a receiving application can retrieve the message. And finally, message with the data has been processed, so it can continue to the next step in the pipeline. So there are some issues and considerations when you are dealing with this claim check pattern, and you can consider the things like when you are deleting the message data after consuming it. If you don't need to archive the message, that's fine. However, keep in mind that blob storage is relatively cheap and it costs some money. However, it can cost some money in long run, especially if there's a lot of data. So deleting that message can be done synchronously by the application that receives and processes the message, or even better, you can use asynchronously, deletion of that separate messages by a separate process. The asynchronous approach removes all data with no impact to the throughput and message processing performance of the receiving application. Again, before doing any decision on that, how long you should store the message or delete that, it's going to be bind into the compliance scenario and client requirement that you are trying to deliver with your solution. Next, storing and retrieving the message causes some additional overhead and latency. So keep that in mind because when you separate the message, There's reference part, there is a claim check part. So it's all will take some time, and it will uh, you know uh, and depending what is the latency of the services that are doing that, it can add up. And you may want to implement logic in the sending application to use this pattern only when the message size exceeds certain data limit. Meaning that if you have a small messages, it doesn't make sense, kind of separate them and have a different reference, because for the small messages with smaller data limits, you can actually, uh, can process that using your message bus. So that's why you can take this pattern and skip the small messages. This approach would result in a conditional claim check pattern where you have that condition to check on the size of the data. All right, that's it. I hope this was kind of good deep dive into at least two of the patterns to see how they are used and how to represent them in the cloud solution providers, or in the cloud platform where you are trying to implement that. However, there are much more into that. If you want to have a good architecture and you want to have a sound architecture for your solution, it's always good idea to go and check them with well architected frameworks that cloud solution providers have in place. And the well architected frameworks are designed to help you understand the pros and cons of decisions you make while building a system on the specific cloud solution platform. In our case, we have AWS, Microsoft Azure, and Google Cloud. By using the framework, you will learn architectural best practices for designing and operating reliable, secure, efficient, cost effective, and sustainable system in the cloud. So I'm going to provide the links for each of these well-architected frameworks on the cloud solution providers at the end of my demo. So stay tuned for that. But if you look at each of these cloud solution providers and what they have in place, you will see that they have common pillars like operational excellence is important for all them, and I would say security is another thing. That's very important. Then we have cost optimization across them. Reliability is another thing. Performance efficiency is also important when you are coming out with your architecture. And sustainability is also important across these clouds. It is just defined a bit differently in each of cloud solution providers. So that said, let's look into some references that you can use in your cloud design pattern. So this is the I'm going these links are going to be clickable on the PDF that I'm going to upload to the GitHub. And let me show you where you can find them before switching the gears here. Okay. So here we showed cloud design patterns. If you want to get those links and references that I'm going to show you, you want to go to this GitHub site and then navigate down to the presentations and then click on the Azure Back to School 2023 and then check the cloud design patterns. And I'm going to upload the PDF here. I'm going to put this link. Hopefully Dwayne can share this with everyone on the, you know, but those references are going to give you very good understanding in terms of where to look. So so let's look at them. So first you will get architectural design center and design guides from the Google. That's one of the things to look. Then you want to get perspective of guidance from AWS cloud design patterns. Then we have, of course, data management patterns from the Azure. We have design and implementation patterns from Azure, and we have messaging patterns from Azure that are all very useful. Then finally, in addition to that, you have some more cloud architecture learning references that I'm going to share, and you can get them again from that GitHub repo where I'm going to upload this presentation that are going to have these clickable links. So you'll get, if you look at the from Azure perspective, there's a number of references that you can start with Microsoft Learn. You can look at Cloud Marathon blog post that I created over time. You have Thomas Maurer, which is the Microsoft employee, has some study guide in place, and this is mostly about Azure architecture and how to actually learn about Azure architecture while getting prepared also for the Azure Architect expert exam. And then we have John Saville, of course. We have labs and exercises. We have Azure Architecture Center and some exam simulators if you are preparing for the exam. But again, you don't have to always prepare for the exam. One of the goals might be get more familiar and you know well more familiar and plus uh, well suited in terms of understanding what are the options that you have as a cloud architect when you are dealing with Azure solutions, AWS solutions, or Google Cloud solutions. All right, that said, in addition to that, I want to share this, QR code for the Azure Solution Architect Expert LinkedIn Learning course, where I'm also sharing these architectural design um, components and services on Microsoft Azure platform. So you are more than welcome to check it. You can also check them actually by going to this website. So we checked and clicking on this Azure Solution Architect Expert exam. If you want to learn more about cloud infrastructure and how you can get started with cloud infrastructure in Azure, then you can look at this bicep course, and you also look at the part one course, which is continuation of that. All right. In addition to that, I want to also share this awesome Azure Architecture GitHub references where you have collection of official and community resources that can help you upskill, your understanding with cloud architecture. All right. That's it. Uh, Next, here we have questions and answers. So if you have any question, I will give you some time here to formulate your question and post that in the chat. But meanwhile, I'm going to wrap up what we covered in this presentation. So we started with the why architecture matters. Then we looked into what is the cloud architecture. After that, we dived into design patterns and what is the cloud design patterns, what are the common things across the cloud solution providers, and how to get started. And we deep dive into a couple of those cloud design patterns. And now we are at the Q&A section. Okay, that's where we are, and I promise to have that. So if you are, if you come up with any question or anything like that, put that in the chat. But meanwhile, I'm going to share certain things here till we get any question or comment. Maybe you will be watching that after hours because you have to attend some important meetings, or it's too early or too late for in your time zone. But these are the basically QR codes for the Cloud Marathoner blog that I'm happily creating for the community. We have Microsoft Learn modules, how to get started. We have awesome Azure Architect GitHub repo that I shared, and we have the LinkedIn learning courses on Microsoft Azure architecture. All these are available for you. You can stop the video here, get the link, and go and check them out. And before going to the last sections, which is the thank you, I want to come back here for Dwayne. Dwayne, can you check, the audience and see if there's any interesting question or anything that came up in
I
the,
have not seen
chat?
any questions in the no questions in the chat, Alhan. Everybody
All
must be
right.
crystal clear.
Yeah, it's crystal clear, or it's too early for, or too, late for the
Too early
audience
or too
to
late or
watch.
whatever. Yeah.
Yeah.
Or they'll catch it on
Timing is,
demand. Or
that's
they'll
why we
catch it
are.
on demand, and they can put their comments in
Yeah,
the
sure.
YouTube channel or
Hmm.
on your GitHub.
Yes. So what I would say is just you put the link there for the presentation, and in addition to that, I will, upload this presentation with the links to the references that I shared for the cloud design patterns across the CSPs. But maybe you have any question, then you can bring one. It's up to you.
I don't have any. No, no, very great presentation. I love how you brought not just Azure but also AWS and GCP into it, because we are in a multi-cloud
Multi-cloud.
world. So so certainly very helpful from that standpoint, that it's not just all Microsoft, even though as MVPs we like to think that way, but it is multi-cloud. Uh,
Yes.
I tend to say that I challenge any organization to not say that they're a multi-cloud organization, because if you think about cloud and consuming cloud in general, if you're
Yes.
using Azure or AWS or GCP, but then like say you're using Azure, but you're using Google Suite, you're multi-cloud. If you're using Workday,
Mm-hmm.
you're
Yeah.
multi-cloud. so I
Yeah.
mean,
That's
I think we're
that's the part of it.
in a multi-cloud world, because everybody's consuming more than one cloud provider. Nobody is all in on one.
Yeah, you are right. You are just to the point. Like even if you have, let's say, as a place AWS shop, right? But you are managing your security and access to the devices using the Azure Active Directory or Microsoft Entra, we should say, right? Because there was a name
Hmm.
change. If you are using Microsoft Entra groups and security groups and all the policies that are coming with the Microsoft suite to secure your solution, then you are a multi-cloud, because not just the workloads that you run on AWS, but it's also the part of the security and identity that you are running on your Microsoft Azure, or specifically Microsoft Entra ID.
Yep,
So that
exactly.
said, I just want to bring it back to the to our viewers that it's not only one cloud, as you mentioned, it's a multi-cloud, but it can also have a flavor of the hybrid, right? Where your customers may have still some workloads that they want to run on-prem, and at that point you need to take those considerations into account. And my I hope that this presentation will help you to give you some ideas how to solve some very critical problems in your architecture, by making sure that you are ready for the failure and you have a plan to tackle those situations. And again, thank you very much, Dwayne and Derek, for organizing Azure Back to School. It's an awesome event where presenters and everybody in the cloud community brings their sessions and share with everyone. And thank you again, viewers, for watching this after hours. You are awesome. Yeah, give a subscribe to this channel. By the way, I never advertise that too much, but subscribe to this channel as you're back to school. Maybe whenever you have time, you are walking or something, you can listen to this episode or any other episodes that have been recorded on this channel. And thank you everyone for watching, or you know watching this recording later on. Thank you a lot. Back to
Yeah,
you.
thanks, Elhan. Appreciate your contributions this month, as always. Always one to first a lot of times to raise your hand and to get a submission in. So really appreciate it. Yeah, thanks to all the contributors. Derek and I could not do this event without you or the viewers. Like I said, like I was saying at the beginning of the episode of the session, that we're getting a lot of traffic, a lot of new subscribers to the channel. Subscribe to it. We do this event every year. As Elhan said, this is the fourth year, and we've grown larger every year. I think this year we topped 70 sessions and over like 66 individual presenters. So you can do the math there and know that people like Elhan did
Hmm.
more than one session as well. So we appreciate that. So thanks everybody.
Yeah,
Have a great
you're
rest of your
welcome. Again,
day.
like
And
follow, yeah, follow the
yep.
Dwayne. Yeah, follow
Yes.
the Azure Back to School. There's a hashtag, and you are more than welcome to give a follow to Dwayne. He has his Twitter handle there. I'll bring my information here so that you can, message me or reach me on the
Yep.
Twitter or LinkedIn. Okay, so let's get connected, guys. Check the Cloud Marathoner, and have a wonderful rest of your day. Thank you, Dwayne.
Yep. Thank you, Elhan.